Hello friends, today we'll be doing a question related to the stability of an discrete time system, and here the impulse response is given. So let's start. So it says that which of the following system is not stable, okay? So we have to find among these two which of these is not stable. So how to proceed for these kinds of problem? For stability, the impulse response must be absolutely summable. Means wherever this impulse response is given and you need to find the stability, then what you need to do is you need to sum that impulse response from n equal to minus infinity to infinity, and it should be a finite number. Okay, absolutely summable means it should be a finite number. Okay, so absolutely summable I can write as finite number. Okay, so this is what we need to ensure. Okay, if it is a finite number, then we can say that okay, the system is stable. If it is not a finite number, then the system is unstable. Okay, so mathematically, how to solve these kinds of problem? So say we take the part A. Okay, so A says that the signal is 1 by 2 power n u of n plus 2 by third power n u of n plus 1. Okay, this is the impulse response. Okay, hn means the impulse response. So what we do is, according to this definition, we try to sum this up. Okay, and we can see whether we are able to sum that up or not. So what we do is we have a limit from n equal to minus infinity to infinity, and we sum 1 by 2 power n u of n plus, because we can sum them individually, so there are two summation signs, plus n plus n equals to minus infinity to infinity 2 by 3 power n u of n plus 1. So this is what we get. Okay, now we are going to sum this up. So what we can observe here is this u of n will be 0 for n less than 0. Okay, so the limit can further be revised from n equals to minus infinity to n equal to 0 to infinity. Okay, and then this becomes 1 by 2 power n, because u of n will be 1 for the values which are greater than equal to 0. And in the similar way, you can also do that for the other signal, and here it is u of n plus 1. Okay, so this will be non-zero from minus 1 to the increasing values. So what we can do is we can further revise the limit from minus 1 to infinity, and for that values, for the values which are greater than equal to minus 1, this will be 1. So it is 2 by 3 power n. Okay, so now what we can do is we can expand this. Okay, so we can expand this, and what we get is 1 by 2 power 0 plus 1 by 2 power 1 plus 1 by 2 power 2, and it continues like that. Okay, this is the first series. Okay, and the second series is 2 by 3 power n, so it goes like 2 by 3 power minus 1 plus 2 by 3 power 0 plus 2 by 3 power 1 plus infinity. So what you can observe here is here you can see that the denominator will become higher and higher. So it, in a way, the next term, okay, uh, of the series will be always smaller than the previous term. Okay, like 1 by 2 power 2 is going to be smaller than 1 by 2. Okay, similarly 1 by 2 power 3 will be smaller than 1 by 2 power 2. So it's a decreasing sequence. Okay, so and also you can see it's a GP, it's a geometric progression, and it's a geometric progression with infinite terms, and we know that the sum is a over 1 minus r. Okay, and here r should be less than 1. Okay, so that's what is being ensured, because here r is 1 by 2 in this case. Okay, in this case r equals to 1 by 2, and in this case r equals to 2 by 3. Okay, so we sum that up, and this is a is the first term. The first term is 1 by 2 power 0 over 1 minus r is 1 by 2. So this is what we get for the first series. And for the second series, the first term is 2 by 3 inverse, okay, or 3 by 2, and after that we go like 2 by 3. Okay, so again we get the sum as 2 by 3 inverse over 1 minus 2 by 3. So if we sum this up, okay, this comes out to be 13 by 2. Okay, which is a finite number. So when it's a finite number, then we can say that the condition that it is absolutely summable is satisfied, and the system is stable. So we can say that it's a stable system. Okay, so I write it as a stable system. Okay, so this is a way of solving. Okay, this is a way of proceeding mathematically how to find whether the system is stable or not by summing the impulse response, okay, and finding it whether it's a finite number or not. That's one way. Another way what you can do is you can simply visualize these functions, okay. So this first function 1 by 2 power n can be graphically drawn like this, okay. This is the graphical representation of this function. What you can see here there is uh, each term, like I told you, like 2, 3, 4, each term is smaller than the previous term, so it's a decreasing sequence. It's going like this, okay. Every term is decreasing, so you can say it's a converging sequence, okay. So it's a converging sequence, so definitely the sum will be a finite number, okay. Again, for the second signal, which is 2 by 3 power n, you can again see that it's a decreasing sequence as we increase the value of n. So again we can see here that it's a converging sequence, okay. So it's a converging sequence, so both are a converging sequence, so in a way they will give us a finite sum, okay, when they are summed up to infinity. So in a way we can say that this is a stable system, okay. So there are two ways. So either you can use this property, okay, directly summing up, or even you can visualize it graphically and it becomes very clear if you see it in graph, okay. So that's one way. Now let's proceed, and so we found that this system is stable, okay. Now let's see what is the state of the second system. So let's proceed. So see, the second system is again I have written in the similar form. Now here I am again summing it up, okay, to find whether it is absolutely summable or not. Now you can see here that again the u of minus n will be non-zero for n less than 0, okay, less than equal to 0. So the limit again has been modified. You can see the upper limit is 0. Earlier it was infinity, but the upper limit is 0 when we are putting the value of u of n, u of minus n, okay, and it will be 1 for that case, so we can put here 1 directly, okay. So it does not matter. So now what we can do it, we can again expand this, okay. So what we get is 2 power 2 by 3 power 0 plus 2 by 3 power minus 1, okay, and 2 by 3 power minus 2. So what we can do is, see, we want to again sum this up. So what I have done here is this will be 1 anyways. Now this will be 3 by 2 power 1, okay, okay, 3 by 2 power 1, 2 by 3 minus 1, because I am inverting, so what is happening is that minus becomes plus, okay. So in that way we have proceeded, so it becomes 3 by 2, 3 by 2 squared, 3 by 2 cubed, okay. Now you can already see that the number which is preceding or which is succeeding is always greater than the preceding number, okay. You can see that 3 by 2 squared will be greater than 3 by 2, and 3 by 2 cubed will be greater than 3 by 2 squared, and so on. So you can see that you can't sum this up, so okay. So it's a divergent series, okay. So here the sum will not give you finite, okay. So already you can see that the system is unstable, okay. The system is unstable. The second part, b part, is unstable, okay. B is unstable, I can write. Again the same thing you can visualize with the help of graph. You can see here that at n equal to 0 it is 1, then it goes at as 3 by 2, then it goes as 3 by 2 squared, then it goes as 3 by 2 cubed, and then it is 3 by 2 ki power 4, okay. You can see that the magnitude keeps increasing and you will not be able to sum this up, so you will find that the system is unstable, okay. So this is how you have to proceed with the problem related to the stability of a system where the impulse response is given, and this will be helpful for you for other questions also, like where you can directly you see the graphically whether the system is stable or not, okay. So thanks for watching this video.